Hello everyone, welcome to Explore Hop. For this example, we're told to differentiate the following function. And the function we're given is the function f of x equals arcsine squared of 3 minus 2x squared. To differentiate this function, we need to apply the chain rule. And just to review, the derivative of arcsine of x is equal to 1 over the square root of 1 minus x squared. So the derivative of f of x is equal to the derivative of the outside function, which is equal to 2 times arcsine of 3 minus 2x squared, using the power rule, then times the derivative of arcsine with respect to 3 minus 2x squared. So times 1 over the square root of 1 minus 3 minus 2x squared squared. Then times the derivative of the inside function, which is the derivative of 3 minus 2x squared. And that's just equal to negative 4x using the power rule. Now, if we were to expand 1 minus 3 minus 2x squared squared, then we have that 1 minus 3 minus 2x squared squared is equal to 1 minus 9 minus 12x squared plus 4x to the power of 4. And this is equal to 1 minus 9 plus 12x squared minus 4x to the power of 4, which is just equal to negative 4. And I'm going to reorder the terms right now. Plus 12x squared minus 8. In common factoring out 4, we get that this is equal to 4 times negative x to the 4 plus 3 times x squared minus 2. So subbing this expression back in, we have that the derivative of f of x is equal to 2 times arcsine of 3 minus 2x squared times negative 4x over the square root of 4 times negative x to the power of 4 plus 3x squared minus 2. And this is equal to 2 times arcsine of 3 minus 2x squared times negative 4x over 2, which is the square root of 4, times the square root of negative x to the power of 4 plus 3x squared minus 2. And from here, the 2's divide out. And this is equal to negative 4x times arcsine of 3 minus 2x squared over the square root of negative x to the power 4 plus 3x squared minus 2. And that's how you find the derivative of f of x. That's it for this example. Thank you for joining us. See you in the next lesson.